In this lesson, we are going to learn about lambda functions, also known as anonymous functions. Anonymous function is a function which is defined without a name. Lambda functions, also known as anonymous functions, are a way to create small, one-line functions without a formal name. They are defined using the lambda keyword and are used for simple, short-lived functions. Lambda functions are useful in Python for various reasons. Number one, concise and readable code. Lambda functions allow you to write functions in a compact manner, reducing the need for defining a separate function with a name. This can make the code more concise and easier to read, especially for simpler operations. Number two, functional programming. Lambda functions are commonly used in functional programming paradigms, where functions are treated as first-class objects. They can be passed as arguments to other functions, returned from other functions, or stored in data structures. This enables the use of higher-order functions and supports functional programming techniques. Number three, inline function definitions. Lambda functions are defined directly within the context where they are used. This eliminates the need for defining functions separately and helps in situations where a function is required for a specific purpose but does not need to be reused elsewhere in the code. Number four, callback functions. Lambda functions are often used as callback functions, which are functions that are passed as arguments to other functions and are called later in the program's execution. They provide a way to define small, on-the-fly functions that can be used for specific tasks within a larger program. Next is sorting and filtering. Lambda functions are commonly used in conjunction with built-in functions like sort and filter. They allow for custom sorting criteria or filtering conditions to be defined in line without the need for writing a separate named function. So overall, lambda functions provide flexibility and convenience in writing short one-off functions without the need for defining formal function names. They are particularly useful in situations where small, temporary functions are needed for specific operations, or when working with higher order functions and functional programming concepts. Lambda functions are much recommended to use whenever we have smaller functions to execute in our Python program. They are widely used for data manipulation and feature engineering, where we have to make smaller changes in larger data sets. The syntax for lambda function is lambda arguments expression. So let's try to understand the lambda functions by taking an example. Suppose we have a number and we want the square of that number as a result. We define a lambda function called add that takes two parameters, x and y. Now, lambda functions are small, unanonymous functions that can be defined in a single line. They are useful when we need a simple function without a formal definition. In this case, the lambda function takes two arguments, x and y. Inside the lambda function, we have the expression x plus y, which represents the addition operation of the two input values. The lambda function simply adds the two values together. Next, we call the lambda function add with the arguments 3 and 5 and assign the result to the variable result. This means we are invoking the lambda function and passing the values 3 and 5 as its parameters. Finally, we use the print function to display the value of result. The print function outputs the result to the console. In this specific example, when we add 3 and 5 using the lambda function, the result will be 8. Therefore, when we run the code and print the value of the result, we will see 8 as the output. Lambda functions can be a concise way to define small, one-time use functions like this addition operation, especially when we don't need to define a separate named function. Now let's take one more example for the lambda functions. Here we define a lambda function called square. A lambda function is a way to create a small anonymous function without a formal defining statement. In this case, the lambda function takes an input x and returns the square of x using the exponentiation operator. Result is equal to square 4. We call the square lambda function and pass the value 4 as an argument. This means that x in the lambda function will take the value of 4. The lambda function then calculates the square of 4, which is 16, and assigns it to the variable result. Print result. Finally, we use the print function to display the value of the variable result, which is the squared value of 4. When we run this code, the output will be 16. Now, this code demonstrates the use of a lambda function to square a number. The lambda function allows us to create a small function in line without the need for a separate function definition. It provides a concise way to perform a specific calculation or operation. So now we understand how to use lambda functions to execute smaller operations. Lambda functions can also be used with built-in functions like filter, map, etc. You will get to use lambda functions a lot if you are into data cleaning or data manipulation or even feature engineering.